Okay, good morning. How are you today? Good. Nice to see you in the morning. I thought after the dinner last night, some of you think that let's sleep more. So you have a very nice dinner last night. Now you spend the time sleeping in the morning, right? But thank you all to come along. Uh, let's move on to another topic, which is planning turbine installation. So you have your turbine, you have designed your turbine, everything is okay. You have selected a site. Now, how you are going to install that? What are the method, technique you need to follow for the planning process of installation? To do that, first of all, you have to do site assessment and feasibility study. That we have talked about before. First of all, you have to evaluate hydrokinetic resource, flow velocity, depth, consistency as the proposed site. So it is the velocity that is the important part. Then you need to have depth of water and you need to have consistency. That means over the whole 12 months in a year, how much power you are generating. So usually you say kilowatt hour. You have your capacity of the turbine, which is 5 kilowatt, and multiply by the hour in 12 months where it is running at full capacity. So that's the first thing, resource assessment. Second thing you have to do, environmental impact. We talked about that before. And third thing you have to think about, grid proximity. How close your installation is near the grid, because you need to add to existing grid. Okay, you don't need to create long power line that will become very expensive. So site selection, assessment and feasibility study you have to do first during the planning process. Next time you have to do turbine selection and design. Okay, what type of turbine is suitable for this particular location? Hydrokinetic turbine we are looking at, which what you need is a horizontal axis or vertical axis based on site conditions. Look at the site there and think about which type of turbine is suitable for that location. Okay, is it the horizontal axis or it is a vertical axis? Capacity of the turbine we have to think about. If you design it 5 kilowatt and then you can put 3 or 4 together in an array, then you get 50 20 kilowatt, whatever capacity you are looking for at that particular location. And then you have to think about what are the other ancillary equipment you need, which is based on mooring system, underwater cables, control system. What are the things that you need? So in the planning process, not only turbine selection and design, but also all the support structure that you need, that you have to think about for this. Then you have to think about how I am going to connect with the grid, whether the actual grid has the capacity to add new power input. So you have additional power coming in, and whether the local grid has that capacity to pass or carry more additional power generated by hydrokinetic turbine. So grid capacity assessment is important. Then at which point you want to connect to the grid, connection point in the grid, and grid is running at a certain voltage and your turbine is generating in another voltage. So you have to scale up. Always you need a transformer to scale up your voltage to the grid, because if you transmit power at a low voltage, you lose a lot of power during the transmission process. So you have to scale it up to we call it kVA, 55 kVA or something like that, scale it up. And of course, you need to have necessary permits and approval from local authorities, grid operator. Maybe you are a small company, independent company, who is putting this hydrokinetic turbine in water, but grid is owned by another company, right? In UK, it is owned by a private company called National Grid. In India, is it probably owned by the government or state? I don't know. But whoever is owning the grid, you have to get permission and permit that your new hydrokinetic turbine energy can be added to that. Otherwise, there is no point generating hydrokinetic energy. Okay. So you have to look at power system design also. Power system design. So that include transformer, is transform your voltage. It includes switch gear, protection system, there is a power surge or things like that, safety and efficient power transmission. Now you look at that, you cannot develop your hydrokinetic turbine in isolation. As I say always T, you have your mechanical engineering knowledge, depth, but also you need collaboration with electrical engineer. Otherwise, whatever power you are generating from the mechanical point of view will be wasted if the electrical system is not designed properly, and you are losing lot of electricity power during the transmission process. Control system is very important. You have to control your power output. You have to synchronize the grid, fault detection, everything you need in a control system. So you have to plan that power design, power system design. Energy storage is very important because most of this energy is what you call is renewable energy, which is intermittent. But hydrokinetic turbine is not intermittent. I think water flow continuously, so you can generate electricity continuously. However, maybe use of electricity at certain time of the day is more, certain time is less. So you are generating excess electricity. You have to store that electricity in a battery now, but maybe there are other systems for storage of electricity that you can think about. Okay, or you can export excess electricity to other state and other places also. So these are the whole system you have to think about. Then once you think about system design, then you have to think about installation and commissioning. Okay, first of all, you have to have all preliminary design process. Then you have to think about, okay, I have got everything ready to go, but how then we going to install it and commission it, that means run it. So you need to have an installation plan that include timelines, how long it will take, where you are getting your resources, and risk management strategy. There is risk. Certain time there may be flooding or monsoon rain or some other unwanted, unforeseen thing happening. So you have to have a risk management strategy, risk planning, risk assessment of the whole installation process. If something goes wrong, what is your alternate method? What is the mitigation to the risk? Risk management is very, very important. So you have to have a timeline, which you are install first, which you install second, which is install third, how long it will take, what are the risks, what are the facilities available there. Those are the things you have to think about. So something, say you plan it to put it in a remote location, that will take 3 months. Everything is fine, but you go there and found there is no accommodation for engineers. Okay, it can happen, right? So if you have not planned that every details, then your process will be delayed. Then commissioning means you testing it for the first time, you run it the first time. So you have to conduct thorough testing and then you have to switch on and see how it works, before you can hand over to the user basically. And you have to have some sort of synchronization with the grid, that is very important, compliance with the grid code and standard. Okay, so lot of thing goes into installing a system. Yeah, planning is paramount here. Okay, then comes operation and maintenance. Okay, you install it, you run it, then what is the plan for your operation and maintenance? That is also important. That means you have to monitor. If it is a new system, you have to monitor the performance. Whether it is producing or running at a highest of efficiency. Okay, so you need to have lot of sensor added to that. You have to collect data, you have to analyze data. So you have to think this is running according to the plan that you set it up. And if there is any issues there, detect issues, you can pick it up and then maybe optimize the operation. So nothing goes correct at the first time. Once you switch it on, you will say it's not working the way you think, you thought, you planned. Then you have to monitor the performance over certain period, and you have to fix the problem. It cannot let it go like that. You need to have a maintenance schedule, which may be a kind of a predictive maintenance or a fixed schedule maintenance kind of thing. There are a lot of technique and lot of AI based technology now coming into play to create a maintenance schedule. We have to think about every 6 months what type of maintenance you do, every one year what type of maintenance you do. Now your turbine is in water, right? So how do you have a maintenance process? You have to design it in a way that if you need it, you can get the turbine out from the water and then you can check it, then put it back again. So during the design process, you have to have a flexibility of, okay, this is my mooring system, this is how I'm going to hang the turbine, but you also need to think about how can I take it out easily from water so I can do maintenance. So you have to have a that design built into your mooring system. Then you have to do regular performance analysis to find out whether it is working the way it should work and ensure efficient operation. Okay, those are the things you have to look at. Then of course you have to meet all the regulatory compliance and reporting method, something like whatever environmental regulation is there, whatever grid code is there, that you have to follow through. You have to keep detailed record and report for the regulatory bodies, stakeholder and your internal use. So keeping data, producing a monthly report or 3 monthly report of how it is performance. These are all important aspect of running a successful hydrokinetic turbine installation. Okay, now we move on to a very important part, which is stakeholder engagement and community involvement. So most of the time our hydrokinetic turbine, when we are thinking about installing, our idea is to put it in remote location where you get the best benefit for the community. Okay, because it's a smaller modular turbine which produce 5 kilowatt, and so you put it where the community needs it. You don't need to transmit electricity generated from a thermoelectric power plant far away from the user. If you can produce it at the location of the user, your transmission loss is minimum, right? So is the important thing is to stakeholder engagement and community involvement. So you have to engage with the stakeholder, including local community, government agency, investor. They will put money in. Ensure transparency and support. And community benefit. You have to explain to the local community that it has got benefit in terms of job creation, in terms of community energy projects. The community where there is no energy, you are producing energy, and also job creation is involved. You are creating job for them. Okay, now, and also risk management. When you create a new system, you have to have a comprehensive risk assessment to identify potential risk to the environment, to the human health and safety, and then you can mitigate against the risk. And always you have to have a contingency plan. That means if there is a sudden equipment failure, what are you going to do? Do you need to wait another 6 months, another 3 months before you can run it again, and things like that? If there is an environmental event suddenly happening, big flood, which you didn't anticipate, what are you going to do? Some contingency planning. What if situation analysis. If this happen, what you do? Though you cannot foresee that, you may not happen, but you need to have a contingency plan. So if I go back to this point again, risk assessment. Conduct a comprehensive risk assessment to identify potential risks and develop mitigation strategies. So at this point, if I ask you just to think little bit about, okay, I am putting a turbine, I am putting a generator, what type of risk is there and what type of mitigation strategy we need to follow? Can you identify any of the risk associated with installing a turbine in a river, and what mitigation strategy we can follow? What are the risks can happen? Anything you can think of. Anyone? Anyone has done any risk assessment in any of your project that you have done before? Huh? Say again? Yes, yes. How? So one example might be you have your installation in water, right? A boat is coming. They didn't notice the boat, your installation. Boat is carrying some passenger. It comes in a heat, and then boat may sink, loss of life, very serious condition. So this is a real risk, right? You put anything in a river and in a waterway, and that could be risk. So what is the mitigation for that risk? What type of mitigation strategy you can make against that? Maybe you signpost, sorry, Professor, signposting, yeah, some sorts of sign, danger, or go that way, turbine in installation there. So you have to have some signposting, so boat can see it, move to another direction. Okay, because most of the people those who are using the water, right, they are very familiar with day to day. They may not think, oh, suddenly you put a wind turbine. They may have noticed it, but when they are going a boat ride or something, they may not think, because they have a 10 years of habit of going in that area, and suddenly you put a turbine and they have noticed it before, or even they noticed it because their habit is built over 10 years, they may not think there is a turbine there. Okay, so you have to make sure that risk assessment is there. Another risk may be cable. How you put the cable? Is it a over hanging or underground, and that type of cabling, because you need to take the electricity out from there to the shore. So that cabling can create a risk also. What type of risk is can create? If it is overhanging, of course we can see the risk, but underground also can be risk. So those who are fishing by net, this cable may tangle up with the net. Those who are doing anchoring the boat, and that can tangle up with the cable also. So yeah, you have to have some mitigation against all of those risk assessment. Yeah, risk assessment you have to do thoroughly. Financial planning is very, very important. Financial planning, how you do, but at the end of the day you make money out of the process. So you have to think about what are the capital expenditure, detailed cost analysis, and what is the operational expenditure. Usually we do it, capex is the capital expenditure, how much cost of everything you build it up to make this system happen, and then opex is operational cost over maybe 25 years and things, and then we take into account interest, depreciation value, and all of things, and then perform a detailed cost analysis, and then we can say what is the levelized, we call it levelized cost of electricity, and if this price has to be low, otherwise nobody will buy from you. And then you have to think about funding. Where is the funding coming from? Who will invest in your project to build this system? Maybe private investor, maybe government, maybe you get grants. Initial work start with this type of grant, which we call it demonstration project. 1 or 2 projects that you build it up, you show it works, community is benefiting, it has some viable economy, and that type of thing can be done with government grants. Then you have to think about incentives, where the government gives you incentive for producing renewable energy project. Many of the time government give you incentive to start off with this type of renewable energy project, so you can start off looking at those are the funding. Okay, now I would like to do a exercise, probably looking at this one. This is very important. Any type of project you do, this is actually quite important. Why I am saying that? Because we used to have research many years ago. Traditionally we do research for research sake. That means we are interested in something and we want to investigate that. That was okay in the beginning, but now the way the economy is that our economy is based on knowledge work. We will not have big industry around. Many of the work is based on your knowledge, and definitely you are into education now and you are move on to a knowledge work, and in the knowledge work you have to use your knowledge to make money basically. Okay, and to that you have to create impact of your innovation or impact of your research, which is means impact means doing good outside the community, in the community, outside your academic environment. Those who are, what I am talking about is those who are doing PhD, they may relate to it. Okay, you are doing PhD, you are doing a nice research, but at the end of 5 years you created a product, a process. You want to see that that is implemented, that is used, that is taken up by industry, by other people, okay, using it basically. To do that you have to get engaged with a stakeholder who has interest in this project. So if I stop here and ask you little bit, think about in this type of hydrokinetic turbine project installation, not in the research lab, not in university lab, in real community. If I want to put it there, who will be your stakeholder? who will be interested in this project, who are you want to convince. So if I can ask one or two, think about that and give me answer. Anybody wants to answer? I give you the first answer. First answer, maybe you are providing electricity, right? So community, local community will be beneficial, number one. Number two, who are the other stakeholder? Those who are, those who are making blade manufacturer. Because you don't do manufacturing, right? You just design it. SolidWorks, you showed me, right? SolidWorks design. Then you have to go to manufacturer. Manufacturer is another of your stakeholder. Sorry, NGO. NGO is a big stakeholder. Yeah, they are there. They can implement this type of small project. Who else? Industry? Industrialist. Yes, good. Businessman. Say again. Government help. Yes, good. Government agency. But who in the government you want to go? Because government is a body, he had got his local representative. But is the local representative what you call member of parliament, or is it power producing company is one? Good. And what is the government? You a power producer? State government. Okay, good. But state government at the end of the day is a person, right? The government employed person or influencing person, those has the power. Yeah, you have to influence the power, right? Those have the authority power. Anyone else? Funding agency. Water resource management. On the river, basically. Okay, somebody might be, yeah, must be authority of the river. Anyone else? Okay, so I tell you another one. This is, I don't know whether I am allowed to say it or not, is that if you want to do some area, you have to manage the middleman and intermediary. Those have the local power authority. Okay, they may not have formal power, they may have informal power, but a local politician. Yeah, so some area you are working, you need to manage those many balance of power distributed among many people's hand, right? So you have to manage them, get engaged with them. Okay, so what is the process of getting engaged? So let's think about how we can get engaged with all the stakeholders. To do that, you need to have a public engagement event for planning and installing a hydrokinetic turbine. Okay, you have to engage through a event, public engagement event. Something like we are here is an event. Similar to that, we have to create an event. So first thing, you have to identify key stakeholders. We have already identified them now through our discussion. Then you identify, okay, I move on to the next one actually, that's better. Yeah, designing a community engagement workshop. Basically, in order to install your turbine, hydrokinetic turbine, you have to develop a workshop, one-day workshop, suppose, with the community engagement in mind. Your objective is to educate the community about hydrokinetic energy and its benefit. You have to educate them. You have to address their concerns and misconceptions. They may have misconceptions. They have some concerns. Oh, we don't need this system into our river. That will create a lot of disturbance to our way of life and things like that. So you have to address your concern. Then you have to gather local knowledge about the river and water resource. Okay, GIS will help you, right? GIS we talked about, but getting local knowledge is vitally important. Those who are living there, they can say how deep is that. I give you an example, is that there is a bridge in Bangladesh. They built it called Padma Bridge. Or Padma, is it Padma Bridge? Recently, it started few years ago. It's a very big bridge. And when they designed it, everything, they said they started doing the work, and they found out they cannot get the bottom of the river. In certain locations, they cannot put the pylon and the structure there. But the local community says usually there is a they call it there is double river there, double river. Somehow they say at this location there is two river. What it means is the double the depth at this location, which is they have local knowledge because they are traveling there. Maybe there are a lot of boats sank there and things like that, and they have a fear that at particular location they call it a two river there. That means double the depth, which no other engineers or other could predict it, and they could not build the bridge there unless you brought in the biggest piling rig to go deep, and that actually increased the cost significantly. So local knowledge is very, very important. And so gather local knowledge, build trust, foster collaboration with them, identify potential local champion and leader support the project. Now this is a challenge. I have my own experience myself. I did work in Kenya to build another system. It's a cooling system I developed and installed in Kenya, in a very, very remote area in Kenya. I was there myself there. So when you do a project, lot of people will come and gather, community, and some of them will help you and champion you, and some of them will not allow you to work. So you have to manage middleman, intermediary, and we don't know who is there because we came from UK. We have a local partner there, but the local partner doesn't know because it's a very remote area. So some people will come suddenly, try to help you, some also hinder you. So you have to find out who can actually help you, who is your local champion. You have to find somebody that will promote the idea to other local community. These are the very important thing to look at. Then what is the outcome you are looking for? The participant came here, they are the local community stakeholder. They go home with a clear understanding of the project and sense of ownership and involvement. That is very important. You may employ them into the project, and you make sure the benefit is so much to them. You explain to them that benefit is so much. They take a ownership. They will think that this is the project for them, ownership. And excitement about the potential benefit. You create an excitement that give you economic opportunity, that give you clean energy and things like that within the community. So these are the things you have to create. How? Use your charisma, right? Or your charm to convince people. Understand what I'm saying? So just a research scientist is not enough. Now you are acting, spreading your charm. Convince the people. Yeah, Mahesh? Possible? Good. So these are the multi-type of skills you need. You understand what I'm coming at? So these are the goal, your goal. But people want something else. Your goal may not align with them. So you have to make sure those people are coming, they are against the project. When they go home, they are excited about the project. They have a ownership of the project and they understand the project. Okay, so you convince them through the whole day. So what do you do? Identify stakeholder. Who should attend? Local community members, fishermen, farmers, women, youth, elders. Every community. You don't just get elders, that will not work. You need youth, young people, those who support you. You need fishermen if they are using the river. You need farmers, they will benefit from electricity. They may have electrical pump, they may have irrigation, electrical irrigation and things like that. Women is very important stakeholder. They can convince the men at the home for the benefit of the project. Local leader, village head, panchayat members. Is the panchayat word is used here? Panchayat member? Yeah, when I type it, I thought, is that the word correct? I just watched it in movie, right? Bollywood movie, not a movie, and then I heard this word, I put it here. So you have to, local council, I guess, right? So you have to get them involved. NGOs, you talked about, community-based organization working in the area. Government representatives, somebody said. Technical expert, project team members, you have to be there. If you are not there, you send somebody else and he may not be able to explain question. How will you invite them? That's very important. How you will invite them. Use local communication channel like word of mouth, community announcement, partner with local leader to spread the word. How you get engaged? Maybe you can WhatsApp them if you know the number, or a lot of people have mobile now, right? So everybody has mobile. So you have to think about how you can communicate and engage with them. But partnering with local leaders is very important. Provide incentives. Why they will come? Why they will come? If you come here for one day, they may lose the income. Okay? So you have to think about what is the appropriate time to do it. Is it daytime or evening time or afternoon time when there will be most participation there? You give them little bit of incentives, something like provide free meals, transportation, small gift. These all helps. Okay? Now in UK, you will be surprised. In UK, when we have our university events like conference like that, participation is usually low because all are busy doing lot of other work. They don't want to come. So one way to attract them is to have the meeting at lunchtime, and in the invitation you need to write lunch will be provided and these are the items. Even you write free lunch will be provided in a big board. So all the text are small, but at the bottom we write free lunch will be provided. And at the lunchtime, only then people will come. Okay, free lunch. People in UK really like free lunch. I don't know why. This is a cultural thing. But if I say I will give you one sandwich free, a lot of people will come for free lunch. There is an attraction for free lunch. I don't know why. It's really surprised me when I went there 30 years ago, and I also like free lunch now. So anybody giving free lunch, even I ask, any event, everybody invite me. If this is not written, I ask, is there a lunch there? Or at least coffee there? Then I will come. Understand? So you have to have some incentive. Then, educational component. Educational component you have. So you have to have simple visual presentation on how hydrokinetic turbine work. So you have to create some poster, right? Big poster, some simple design that will attract people. You explain to them how it works. It will not impact their life, those type of thing. Benefits of renewable energy for the community. That means they will get electricity access, reduced reliance on fossil fuels. They don't need to wait on diesel fuel, polluted environment. They will live in a clean environment, nice environment. And you explain the environmental and social impact, positive as well as negative, and potential challenges. The fishermen may say, oh, this will destroy my fishing. So you have to convince them, no, we'll have fish-friendly turbine. There is no impact on the fishing. You will explain to them, convince them, okay? Interactive activity. You create some activity for them. Those who comes, they don't just sit there, then you engage them. So ask them, what are your energy need? Ask them individually, what is their energy need? How can this project benefit your daily life? You ask them. Okay, your daily life, how this new project will change your life. You have a small model, take a small model of hydrokinetic turbine, maybe a 3D printed turbine, and show them this is the thing. This is, you will put it on water. Okay, tell some success story from other countries. Maybe tell a story from Colombia, similar experience, or from Nepal. I will give you example from Nepal also, okay, later, or from Burma, or maybe in India also, where this is implemented. Explain to them, giving a positive story. Then seek feedback from them, question and answer. Okay, you can do some mapping exercise, brainstorming exercise. Then identify key location for turbine installer. Local knowledge, as I say, local knowledge is very, very important. I can give you GIS data, but local knowledge is important. That fishermen, you engage with the fishermen, they will take you to the spot. Okay, this is good spot, this is not good spot. This is where I do fishing, you put your turbine here. Okay, local knowledge is very important. And let them make a decision, simulate decision making process with the community in the planning, in the project planning. Let them have a stakeholder ownership. Okay, get them engaged with the project planning. Okay, ask them what is the best time to install. Is it summer, is it winter? Can you help us taking these equipment to the site and things like that? Can you employ few of them in this project? Okay, this type of community engagement you have to think about. Logistics and planning, venue. Okay, so everything you have to think about. See, every details I'm giving you, every minute details of the how to create a community engagement project. Venue, where is that venue will be? Central location, accessible location, maybe community hall, maybe a school, open space near the river. That's a good place where you gather people. Timing is important. Timing is convenient for the community. So you have to think about in the weekend, weekdays, afternoon, evening, what is best for them, not what is best for you. What is best for them, at what time they can attend. Then you have to take your poster, video, slide, maybe in local language. Maybe your language is English, my language is English, some local language is Bengali or some other. In India, maybe there are many, many languages, right? Maybe how many? Up to 100, 200? 50,000 language. So 60,000 language, see? So you have to take an expert who knows the local language also, right? With you. Excellent. And then language and culture. Use the local languages and dialects. I told you, right? 60,000 is very difficult to manage, but you have to do it. Incorporate cultural elements, traditional music, traditional food, ritual to make the event more engaging. Okay, don't go from here, take your own food, own music, own culture. Engage with the people there, right? So I'm giving you, what I'm talking you, it is quite obvious, but we don't follow that. That's why I have break down every details of how we create a workshop for community engagement. Okay, so then you have to think ourselves. We have to find a facilitator who will introduce and run the show. Okay, so you need to hire and train a local facilitator who understand the community's culture and language and who will run the show. And also you need to have a technical expert to explain the turbine technology. So you need a facilitator who knows the local culture, who can engage with the people, but also at the technical level you need. So in this community engagement event, you need a coordinator, you need presenter, you need moderator, you need note taker, you need logistic team who will handle setup, food, transportation. Note taker will document and feedback. So a lot of things goes on, and probably none of us I have engaged myself with many of these activities, community engagement, because we want to take our research to create impact. We want to take our research from our university into community where it will be used. But any one of you have been involved with any type of community engagement workshop before? Anyone? No, it will be quite interesting if you even arrange similar thing or get engaged with type of thing. Is very important to make your project a success. Acceptance. Okay, then it should not be on off. You have to follow up, and it has to be sustainable. Next step, when you have finished the project, you create a summary of the workshop outcome with the community. Then you establish a community advisory group to continue engagement. So take 5 people from the community, they will be advisor to the project. So when you are doing the project, they will come time to time and advise you. Okay, so they will feel they own the project. Now this one is also important if you are doing any research project. Out of forget about this community engagement. I mean, this is the end product. But if you are in the start of a research project, any research project where you are designing a hydrokinetic turbine, you are doing some lab testing in your lab. In that case, also it is important to have a industry advisory board, not community, industry advisory board. So you can take 1 or 2 industry around and tell them, please, can you spend 1 hour in every 5 months, 6 months in my project? Come see the project, tell me what is your advice on this project. That's it, nothing else. And have a sandwich with him, or maybe lunch, tea, coffee, 1 hour. He will come, look at your research progress and give you some advice. That's it. So that then he will remember when you finish your research project, if you want to take it into commercialization, then those people can help you. So any project you do at a university level, those who are doing postdoc or PhD, it is a good idea to have a advisory board, just to invite 1 or 2 of them, 3 of them. Every research project we do, we create a industry advisory board of volunteers, and they say, okay, we want to work with you, give you advice from time to time, nothing else. It's an interesting way of engaging. Long-term engagement is very important. So you keep updated with some newsletter, some type of information to the community, how the project is progressing, because you do this activity at the planning stage, and your project may start after 1 year. So you have to keep them informed continuously what is the progress. You can actually train some local technician for maintaining the turbine for future. Opportunities for community member to invest or benefit economically from the project. Project can create some economical growth, some new business that they haven't done it before, okay, to the project. So a lot of engagement activity you can do. Okay, is that clear? So that's a related to how we engage with the community. Okay, I give you a details map of doing that. Now going back to grid connection, because if you have an installation, you have to connect it with the grid. So to do the grid connection, what you need a turbine, rotor and blade. This is our mechanical part. This is our expertise. As I say, this T, we are here. This is our expertise. Nobody can beat us. Nobody can tell us anything. We are the expert. But in this level, we are not expert. We just have little bit of knowledge. And that knowledge include generator, AC DC type generator, power electronics, which involve inverter and converter, which convert AC to DC, DC to AC, depending on your need, mooring and anchoring system. Here you may have some mechanical expertise, and control system. There we have some expertise, but not a lot. But these are the basic system you need to have a hydrokinetic turbine. What is the energy conversion process? Kinetic energy of water to mechanical energy, to electrical energy. So power electronics is very important in converting and conditioning electricity. Power electronics. This is a specialized area. We need help from my electrical engineering friend. Yeah, you cannot do your project successfully without their help. You have to create a team. Why? Because we have to think about 100% efficiency. We don't lose power. We may produce lot of mechanical energy, but we are losing in the electrical side. So you need to have energy, importance of efficiency in total energy. That means you need support from electrical engineers and power electricity. So some grid connection basics. I don't know myself that much also in details. I can give you only surface knowledge. My knowledge is also surface in this area because I am not an electrical engineer. What is electrical grid? You have seen the electrical power line that include transmission line, that includes substations and transformer. The function of this substation and transformer is to scale up the voltage, so you can transmit it and then reduce the voltage, so it comes to your home at a voltage of what is that, 220 volt to 250 volt in India and 50 Hz AC cycle. But when you're transmitting, that is 220 kilovolt, I think. Massive voltage you are transmitting power. Okay, so these are the work of substation and transformer. You have to synchronize frequency, voltage and phase. It's a three-phase voltage coming, AC coming. It has a frequency and it has a voltage. So you need to synchronize. So one of the challenges of integrating renewable energy source into electrical grid is these are intermittent. So you need to have different type of control mechanism. So that is the grid connectivity. So power electronics play a key role in converting. So you need inverters in converting DC to AC. Then you have to grid tie in inverter for synchronization. Then you need power conditioning for stable grid integration and importance of power factor correction. These are the electrical role. As I say, you need to know a little bit about what is the function of transformer, what is the function of AC to DC and DC to AC, how is synchronized and make the grid stable. So there are a few components for each of these. Basically we are calling it converter and inverter. Usually you receive DC electricity from hydrokinetic turbine generator, but you cannot transmit DC for a long distance, right? So you have to convert that into AC. Then you have to filter it, shape it, so you can send a smooth AC current through the network. So DC current, you know, fixed DC, direct current, convert into AC, and then you have to create filter it. That means you only allow few frequency, high frequency you may cut it out. Any is the noise in the fluctuation, cut it out and send a very smooth AC waveform. And then delivers AC electricity at the required voltage, frequency and phase for the grid connection. So DC to AC conversion and AC transmission. Okay. Power conditioning system. When you condition the power, what are the key element? Key element is inverters, which convert DC power of hydrokinetic turbine into AC power and ensure synchronization with the grid. So you need inverter, you need some filter, remove some noises and things like that from the power, send you a smooth current. Then you need voltage regulation kind of thing. You have to maintain a fixed voltage. You need to have a frequency converter to give you 50 Hz of frequency or 60 Hz of frequency. If the frequency is high or low, because you are rotating at a high speed, so you have to balance those. And energy storage system or backup system you have to create from the power conditioning setup. Okay, as I said, there are three types of grid usually. One is on-grid system. So whatever you are producing, your electricity feed directly into the grid, existing grid, or is off-grid system. That means is a standalone system, not connected to national grid. So you generate your electricity, you just supply 50 houses here. So local grid, off-grid we call it, local grid system. It's not connected to main grid. And then you can have a hybrid system where is main grid, microgrid, sometimes that electrical people talk about, and also combination of different renewable energy coming into play, solar and wind. Okay, so usually current trend, our existing electrical system is that we produce electricity in big power plant and we transmit long distance to user. The future is producing electricity where you need it, in the community. Okay, then you don't have the long transmission line and long transmission loss. Is supplying electricity to off-grid community. So what are the grid integration challenges? One of the challenges is going back to velocity again. Water flow, it can vary seasonally or tidal cycle. Over 12 hours or 24 hours, flow can change. So that variable flow produce variable electricity. And how you then establish the grid when you're continuously producing variable electricity? So you can do that by power electronics and things like that. That's important. You have to think about infrastructure requirement. This is a big challenge. Subsea cables and substation. When I say subsea, is actually sub-river, right? River. So underwater. If you have one underwater cable, you need to have a very good insulation. It doesn't soak up water and things like that. It's not damaged by anchoring. It's not damaged by boat and thing. So it's very, very important. And also grid, if you want to connect your electricity into the grid, you have to go through regulatory and permitting hurdles. You have to overcome those things. So as a practical engineer going into the field, putting it on, generating electricity actually take lot of planning, lot of process. Not only on the technology side you are the expert, as you say. In mechanical engineering side, you need to work with electrical engineer, hands in hands. But then you have to manage lot of community aspect of convince people that you have to put a water turbine here. Okay, energy storage, another big challenge, because these are intermittent energy. How you store energy is a big challenge. So what you need to look at, what is the role of battery? For the time being, we are thinking about battery, to store energy in battery, but in future we'll move on to other technology to store battery. Okay, so you have to think about how you integrate battery. And so the final point I want to make in conclusion is that is very important. Hydrokinetic energy will not be working on its own, because the power output I am already mentioning is about 5 kilowatt from one turbine. If you put 10 turbine, then it will be 50 kilowatt. To get into megawatt scale, it's not, you need many turbine, and that is not the role of hydrokinetic energy, to provide megawatt size. Its role is to provide kilowatt size turbine, right? And so you have to mix it with other renewable energy source, and these are all intermittent. Sometimes it's producing, sometimes this is producing, sometimes that one producing. So how you balance the grid, how you balance the network, how you integrate whole system is a interesting concept. Okay, and that's the importance of hydrokinetic turbine into energy mix. So what you need to do, because we also don't see the hydrokinetic turbine used everywhere. So what you need to do, first of all, we need to do research. And some of you, this professor here is Mahesh here and other PhD student there, or another PhD student and another PhD student there. They are doing research, and you, when you are coming from MTech, BTech, you may go into research. Not all of you need to go into research, but some of you will go into research. And then it's important to come up with, at the end of the day, you need to come up with a cheaper blade. Money talks. Money is important. So whatever you do, you have to make this electricity cheaper than other source. And the more research you do, you can come up with better, efficient, cheaper solution. Then you have to influence some of the policy to help support it. Maybe government put more incentive, put more upfront money, or invest money into research. Those are the government policy. That this year I am to put 5,000 hydrokinetic turbine in a river in India. So that's the government policy. So that type of policy. Now government may not come up with a policy, right? But you are, as I said, you are expert in this area. So you have to convince the government. You have to engage with the government, convince the government. You have to work with local politician. Maybe you don't have a reach from here to Delhi, but you have access to your local MP, MLA, local politician, and you try to tell them, invite them in your event, tell them this is the research I am doing, this is the research I am doing, this has got future, so help us change the policy. Change the policy. So my research, my work, my expertise will be used. And also investment from the government is needed. Maybe private sector investment is needed. But that again goes back to research. And the research focus will be, whatever you do, at the end of the day, you have to make it economical. It still is very expensive. So that's why it's not installed. And also there is no awareness of this technology. Your professor can tell, but how much is the awareness of this policymaker or investment banker or others in this technology compared to wind energy? Wind energy, solar energy is well in advance, but whether this technology is well known, I don't know. We have to, it's our job. Nobody will take it. Yeah, if I am the expert, I have to keep my job, right? At the end of the day, I have my personal interest, because I have to keep my job because I am the expert in this subject area. So to keep my job, whatever is needed, I have to do it. That include talking with the policymaker, investment banker, and creating noise that this is the technology I developed, this has got this future. Just spread the news. I am the expert in this area and this has got this future. Why don't we implement that? Okay, so it will be depending on us how you promote ourselves. Okay, so thank you for your attention. As I said, we are moving slowly from the technology into various aspects. So holistically, we can make this hydrokinetic turbine implement. Our objective is to see it is in the river, not in the research lab, but into river. And to see that, what we need to do, we have to do a lot of work. And those are the things I am slowly getting on. Okay, rather than technical aspect. Technical thing is there also. You may have learned about how to design a blade and run some CFD modeling from Professor Sibayan, but I am looking at broader area. Is that okay? Okay, so thank you for your attention. I think I took more time, but I will stop now and Professor Sibayan now come and give you a talk. I have another talk with you at 3 to 5 today. Okay? Thank you very much for your attention.